Hi guys, today we're going to look over 2018's Paper 1 Higher Chemistry, and in the next video we will go over the second half. Soluble salts are formed by reacting metal oxides with acids. Give one other type of substance that can react with an acid to form a soluble salt. Metal carbonates or metal hydroxides or alkalis. You can even simply just say a metal. Next we have question 1.2. Calcium nitrate contains the ions Ca2+ and NO3-. Give the formula of calcium nitrate. Now notice how the calcium has a 2+ charge and the NO3- is only just a minus. Therefore, if you want to cancel them out, you're going to need 2 lots of NO3- just to balance out with the 2+ of the calcium. So the answer is going to be CaNO3 in brackets and then 2, because you have 2 lots of what's inside the bracket, which is NO3. Describe a method to make pure dry crystals of magnesium sulfate from a metal oxide and a dilute acid. Now first of all, you need to think about the practical you learnt and just adapt it to suit the question. It wants crystal of magnesium sulfate. Therefore you're going to need sulfuric acid and magnesium oxide to form the crystal magnesium sulfate. So we're going to talk about those two quite often in the answer. So you can say pour dilute sulfuric acid into a beaker and add an excess of magnesium oxide. Now this is just to make sure that all the magnesium oxide actually is reacting with the sulfuric acid. Next you stir it with a glass rod until you see unreacted magnesium oxide kind of floating in the beaker. Now simply just filter the solution with filter and filter paper, and then once you have your pure solution you can just put it into an evaporating dish and set up some kind of water bath. You can use tripod and gauze, heat-proof mat and Bunsen burner, and a beaker of water which you just put the evaporating dish on. Now you're just going to heat the evaporating basin for about 5 minutes and you're going to remove the dish. Now you're going to leave the dish to crystallize, and then after a day or so you can just take the crystals out and pat them dry with filter paper, for example, and you're done. You have magnesium sulfate crystals. 2.1. Iron pyrites is an ionic compound. Figure 1 is showing a structure of it. Determine the formula of iron pyrites. So if you look at figure 1, you can notice that 1 atom of iron is actually bonded with 2 atoms of sulfur. So simply it's FeS2. 2.2. An atom of iron is represented as Fe, and it's given you the numbers 56 and 26. The proton number and the relative mass number. Give the number of protons, neutrons and electrons in this atom of iron. So you're given the relative proton number at the bottom, 26. So there's 26 protons. This must mean the number of electrons is 26 as well, because they have to cancel out the positive and negative charges. The number of neutrons must be 30, because 30 plus 26 is equal to your relative mass number of 56. Remember that electrons have almost no mass at all. Therefore, you're going to completely ignore electrons when working out the neutron number. Next, 2.3. Iron is a transition metal. Sodium is a group 1 metal. Give 2 differences between the properties of iron and sodium. It's asking for properties here, which is just physical values of the object. It's not talking about the structure. You can say that iron is a transition metal and it can be used as a catalyst, which sodium can't. And another point you can say is that iron forms a colored compound where sodium doesn't. Nickel is extracted from nickel oxide by reduction with carbon. Explain why carbon can be used to extract nickel from nickel oxide. Carbon is more reactive than nickel, and this means it can take its place, and that's called displacement. You get 1 mark for the keyword of displacement or displace, and you need to say that carbon is more reactive than nickel because that is the condition required for it to displace nickel. 2.5. An equation for the reaction is that calculate the percentage atom economy for the reaction to produce nickel, and it's given you the relative atomic masses and the formula. and it says give your answer to 3 significant figures. It's asking us for the economy for nickel, and nickel has a relative mass of 59. What we want is nickel. Now to make the nickel, we've actually needed nickel oxide and carbon, which have a total mass of 87, which is just 75 plus 12. So to make our 59 nickel, we actually needed 87 of nickel oxide and carbon. So the economy would be 59 over 87, which is 67.8 to 3 significant figures. A common mistake is forgetting to put it to 3 significant figures. If you don't do it, then you lose a mark, and that's an easy mark lost. I recommend circling that number, 3 significant figures, in case you forget to do it at the end. Next, chemical reactions can produce electricity. Which of these combinations would not give a 0 reading on the voltmeter in the figure 2? So to actually get a reading of voltage, you need a chemical difference, some sort of charge difference. Now a charge difference is set by having a difference in reactivity between your 2 electrodes. If you just simply have copper and copper together, there's no difference in reactivity, there's no difference in charge, therefore there's no charge difference, and so there's no voltage made. So it can't be copper and copper, it can't be zinc and zinc, so we're left with 2 options, the bottom 2. Now a key thing to note is that the electrolyte also plays an important role. If you have an electrolyte of water, then the ions can't move really well, really freely. They work well in the salt solution, which is sodium chloride solution. So the answer by ruling out the wrong answers is the third option. 3.2. Alkaline batteries are non-rechargeable. Why do alkaline batteries eventually stop working? This is simply because one of the reactants is used up and it's ran out, so it cannot continue to give out voltage. Why can alkaline batteries not be recharged? Well, you need to consider why batteries are rechargeable, and they are rechargeable because the reaction is reversible. So if it's not rechargeable and the battery isn't able to be recharged, it must be because the reaction in the battery is not reversible. Hydrogen fuel cells are rechargeable. Lithium-ion batteries can be used to power electric cars. Complete the balanced equation for the overall reaction in a hydrogen fuel cell. First of all, hydrogen is reacted with oxygen to produce water in the hydrogen fuel cell. So first we fill in oxygen. Now we need to consider both sides of the arrow. On the right side we have 2 hydrogens. On the left side we also have 2 hydrogens. But on the right side we have only 1 oxygen, but on the left we have 2. Therefore we have to put a 2 in front of the H2O. Now we have 2 oxygens on the right side and 2 oxygens on the left. But now we have 2 lots of 2 hydrogens on the right side. Now we have 4 hydrogens on the right. So to balance it out, we're going to put another 2 behind the hydrogen on the left side. Now we have 4 hydrogens on each side and 2 oxygens on each side as well. 3.5. Table 1 shows data about different ways to power electric cars. Evaluate the use of hydrogen fuel cells compared with rechargeable lithium-ion batteries to power electric cars. Use Table 1 and your own knowledge. This question is very simple and you can easily gain all 6 marks. Most of those marks come from reading off the table and just rewriting what's on the table. So as a start, you can say that hydrogen fuel cells take 5 minutes to recharge where lithium ions take 30 minutes. Next, hydrogen fuel cells can go up to 415 miles before another recharge is needed, where lithium ion can only go up to 240 miles. And you can also say the distance traveled per unit of energy in kilometers is 66 for lithium ion, where it's only 22 for hydrogen fuel cell. In addition, the cost to recharge the batteries is £50 for a hydrogen fuel cell, where it's only £3 for rechargeable lithium-ion batteries. And the minimum cost of the car is £60,000 for a hydrogen fuel cell, but it's £18,000 for rechargeable lithium-ion batteries. After you stated the information on the table, you need to use your own knowledge to back up your statement, and then finally, if you have time, you should include a conclusion to summarize what you've explained. So you can also say that making the hydrogen fuel cell may be non-renewable, as it may require the burning of fossil fuels to actually make it. But in contrast, you can say that hydrogen fuel cells are very, very efficient, unlike lithium ion, and generally they take up more space, which is a bad thing for cars. And then in conclusion, we can see that in general, hydrogen fuel cells are more efficient, but they are actually more expensive. And the lithium ion batteries are cheaper overall, but they are slower in general. Question 4. Figure 3 represents different models of the atom. Which diagram shows the plum pudding model of the atom? The plum pudding model is where you have a ball of positive charge with random negative charges scattered in the atom. And the only one that shows this is option B. Which diagram shows the model of the atom developed from the alpha particle scattering experiment? You can take away B, D, and E, which leaves us with A and C as a possible answer. The thing about A is that all the shells are equally distant from each other, and the scattering diagram does not represent that information. So therefore it must be C. 4.3. Which diagram shows the model of the atom resulting from Bohr's work? His work actually told us that electrons are separated in shells from the nucleus, and the only option showing us this is A. C does not show us this because it's not showing distance in proportion to the nucleus. Define the mass number of an atom. This is simply the mass of the proton added on with the mass of the neutron, and that's how you get the relative mass number for the atom. 4.5. Element X has two isotopes. Their mass numbers are 69 and 71. The percentage abundance of each isotope is 60% for 69 and 40% for 71. Estimate the relative atomic mass of element X. You can quickly fill in the numbers in the formula to give you the answer. So you can do 60% of 69 plus 40% of 71 all over 100%, or just all over 1, and that should give you an answer between 69.5 and 70. 4.6. Chadwick's experimental work on the atom led to a better understanding of isotopes. Explain how his work led to this understanding. It's actually 3 marks, so you need to give 3 points. Firstly, what did his work lead to? Well, Chadwick's work led to the discovery of neutrons. And for the second mark, why is it important and why does it link atoms and isotopes together? So how does the neutron link to atoms and isotopes? Well, the same elements which have different mass numbers are actually isotopes. So this means that isotopes are the same element, but they have a different mass number. And this different mass number is due to the fact that there are a different number of neutrons in the element. So with these 3 points you get 3 marks. Discovery led to neutrons. Isotopes are the same element with different mass numbers, and their different mass numbers are due to the fact that they have different neutrons. You can see how we're linking all 3 points back to each other. We're linking atoms, isotopes, and Chadwick's discovery, which is neutrons. A student investigated the temperature change in displacement reactions between metals and copper sulfate solutions. Plot the data from table 2 on figure 4 as a bar chart. So firstly, what I would do is look for how many boxes I would assign to each metal. Now there are 10 boxes along the bottom and we have 4 metals. We don't really need to use all the boxes. So what we can do is leave out 2 boxes and just use 8. And that means we have 2 boxes for each metal. So now I'm just going to add little lines on the bottom which show me where the barriers are for each metal. Now we need to think about the y-axis and how much up it should go. What I normally do is just think of a number and go up by that amount of times. Now we have a maximum number of 43, so the bar chart should be at least 43 up. I'm going to try going up in 5 first, so we have 5, 10, 15, 20, 25. It doesn't go up to 43, so now I'll try 10. So 10, 20, 30, 40, 50. It fits nicely. Now if 10 didn't work, I would try 20, maybe 25, 50, 100. So now it's just a matter of plotting the data, which is really simple. 5.2. The student concluded that the reactions between the metals and the copper sulfate solutions are endothermic. Give one reason why this conclusion is not correct. An endothermic reaction is where temperature from the surrounding decreases and energy goes from the surrounding to the actual reaction. And we can see here that temperature actually increases, and this means that energy is given off to the surroundings. Therefore, this reaction is exothermic. 5.3. The temperature change depends on the reactivity of the metal. The student's results are used to place copper, iron, magnesium, and zinc in order of their reactivity. Describe a method to find the position of an unknown metal in this reactivity series. You can answer this question in a number of ways, but the way I find easiest is by doing the experiment you're most comfortable with. For me, I've done lots of reactions with magnesium and hydrochloric acid, so I'm just going to use that for all the metals. So I'll just say to set up beakers full of hydrochloric acid of the same volume and concentration and put thermometers in it, and simply add each metal to each beaker and measure the highest temperature it goes to. Another way you can do this is using a stopwatch and just measuring how much time it takes for it to disappear, and then the faster it disappears, the more reactive it is. But in this case, the higher the temperature change, the higher up it is in the reactivity series. For the last mark, just say something you will control. So you will control the mass of each metal added to the beaker and the concentration and volume of the acid used. 5.4. Draw a fully labeled reaction profile for the reaction between zinc and copper sulfate solution on figure 5. It's only 3 marks, so we need to draw 3 key things. First of all, the reaction is exothermic, so we must have the reactant line on top of the product line, and we must connect it with a curve. For the second mark, we have to label the change in energy, and the change in energy is negative, which should be shown. For the final mark, show the activation energy, also known as EA. If it was more than 3 marks, it may require me to be more specific with the reactants. Like in the reactant line, I would put zinc and copper sulfate instead, and then in the product line, I will put zinc sulfate. But it's only 3 marks, so we only need these 3 key things. Well, that's the end of this video. The next video, we will finish the paper, and then we'll look at 2018's paper 2.